All right, welcome back to the studio here at microcenter. And today we're going to do an Arduino sort of introductory series. This is branching off of our Intro to Electronics series because we wanted to focus solely on Arduino and sort of the basic fundamentals of microelectronics and things of that nature. So walk us through, Andy. What do we got over here?
So what we have here today is the Arduino Uno R4 with Wi-Fi. Now this is their latest board. Most people are probably familiar, if not with this, with the traditional Arduino Uno R3. And that's been around forever at this point, and it's been kind of the go-to de facto standard, right?
So if someone bought an Arduino at microcenter, and they have no idea what they're doing. The goal of this video is to sort of introduce you to all of this and really just guide you along just through everything, right? And we have a couple of guides that we're going to follow along here that's provided by Arduino, so that's going to be kind of cool.
Yeah, so the Arduino, one of the nicest things about the Arduino development environment and Arduino as a whole is there's so much content, projects, resources, everything out there for the Arduino. We're going to start today kind of at the hello world, so to speak, and we're going to dive into the IDE and do some of the very basics.
So looking at the board, right, you have your input pins, you have some other pins here. Like if someone just bought this, what are they looking at?
So we've got a lot of stuff going on, especially on this version, but I'll kind of break it down. So you're going to be familiar with your power input. Your power and data is going to come in over USB-C. Over here you have a button to reset the board completely. So sometimes code could get hung up, or you're still in a different state and you want to restart the program, so you would hit that button. You do have another option for power here. And what we're powering is all of the electronics on the board, but specifically we're powering this microcontroller right here. This is the brains of it. Now, in conjunction with the brains of it, on this board, they've added another brain, so to speak, with a Wi-Fi module. I believe it's an ESP32 type of Wi-Fi module, but that's a new addition to the Uno series.
Okay. So brains with Wi-Fi.
Brains with Wi-Fi, and
internet brains.
Yes, this one can connect to the internet.
Right.
Then we have what is very common. These are the headers for the digital input and output pins. And basically what they are is they allow you to talk to external things, such as LEDs, sensors, potentiometers, like knobs that you turn on a guitar amp. And then over here you have some more headers, and inside of these headers there are analog pins. And what that means is that it can read various voltages, or like a potentiometer, it can tell you where the potentiometer is at. And that's handy. Most of the pins over here are what are considered digital. We'll talk and get into what you can do with analog versus digital. But they kind of have them broken out that way. Digital on this side, analog over here in these first couple.
Okay. And so when you're getting started with this, it's all about inputs and outputs. I remember that's something you told me about, right?
Yep.
Can you describe a little bit about that?
Yeah. So an input could be as simple as a button press. If you had a microphone hooked up to either analog or it had a digital output somehow, you could do, based on sound, could be an input. So basically a loud sound triggers either a relay or turns on a light or starts some other function in the code. Let me think, what else do we have? We have inputs that could be specifically like this guy here. That's an infrared receiver. And then this is an infrared transmitter. So your output is the infrared transmitter. So it transmits the IR code. And then the receiver is what receives it back in and translates that code back to the processor. Once the processor receives that code, your code has told it to do X.
Right. Well, that's kind of cool. It's like a little remote control action there.
Yep. Yeah, Arduinos are great for IR projects.
That's really neat. So we have this set up here.
Yep.
And we're going to dive in. We have it plugged into your computer. What's going on over there?
So on my computer, I have the Arduino Integrated Development Environment, or IDE for short. And what this does, it allows us to code on the computer and then send that code over the USB cable to the Arduino itself.
Right. Okay.
And Arduino's IDE is specifically made for programming Arduinos or other microcontroller boards, such as the ESP32 that's on here.
Okay. Cool. And so what are we going to start with?
Well, inside of the IDE under examples, we're going to start right at the top with the basics, and we're going to go right into the first one.
Okay.
This is called analog read serial. So to put that in other terms, what we're going to do is we're going to look for a change.
Look for.
We're going to look for. So what we're going to do is we're going to look for a change on analog pin 0. So now I've already hooked up this white wire to analog pin 0, and we'll talk more about where it's going to. But again, back to the name, analog read. So we're going to read that analog pin. And then serial means we're going to transmit messages or data back to the computer, so the computer can see where the device is at with that pin.
Okay. Interesting.
So once you've got the basic code up, a lot of times it'll have these comment sections at the top where it will tell you how to set up the circuit. This one's not super full of description, but you've got attached the center pin of a potentiometer, which is what we did, to pin A0, so this white cable is talking to the center pin of this potentiometer. And you may be familiar with larger potentiometers, things that you would see on like a guitar amp, like I said, or on a stereo. This is a small breadboard version. These will often be found inside of a product to set some sort of high or low point.
Right, yeah. I've seen these in some cameras. You can use it to like change different settings, like, yeah.
Yep. So what we have is this potentiometer, the middle pin of it, there's 3 pins. The middle pin of it goes to the A0 pin, the analog pin.
Right.
The outside pin, this one goes to the ground.
Okay.
And then this one on this side goes to 5 volts. So basically what it's measuring is how much of 5 volts is going back to the board.
Okay, got it.
So that's what it had us do. Now if we take a look at the code, that's it. That's the whole code right there.
Walk me through the code here. So
Okay.
this is in the IDE, so it's already set up for you. So all you have to do is the hardware side, and you can just run this and go. But what are we looking at?
So what we're looking at is the first part is the setup. And the void setup is where you'll kind of announce some things or tell some things to the program that you're going to need. And for this one, what it's saying is we're going to use the serial bus, or we're going to use serial communication to talk between the computer and the Arduino after it's programmed.
Okay.
Now, it's going to use USB, Universal Serial Bus, to program it, and then invert it, and then backwards, we're going to use it to read off of the device. So that's what that piece is. So it's just the setup. As we go through these examples, you'll see more and more things coming into the setup for different reasons, but we'll get to that when we get to that. And then this piece here is what's called the loop. So just as it says, the loop runs over and over again forever. So this is kind of what sets microcontrollers apart from a single board computer or a computer. Microcontrollers are really meant to have a processor that just does something over and over and over again without fault, not relying on any number of softwares, registries, all that good stuff that could potentially interrupt a process. It's going to be very solid, just doing what it's told to do.
Okay.
Now that could have some interruptions in it that are programmed, like if the light gets too bright, turn off the light. Or if it gets too hot, turn off the heater. But for this case, we're just going to read those pins. So that's the loop that's going to go over and over and over again. And then we are going to do what we said. We're going to read the analog value on pin A0 and we're going to call that sensor value. We're going to give it that name, and then we are going to print the line, print ln, serial over the serial, that sensor value. And then we are going to do a 1 second wait or delay. So what we'll see, which we're actually already seeing down here, is the value of that potentiometer. You can see it's already changing a little bit without even touching it.
Oh, interesting.
And that's just kind of like noise in the circuit.
Sure. But and it's refreshing every 1 second, polling every 1 second, and we're just getting live updates there.
Yep.
Interesting. Okay.
So if we hadn't been there already, what we would do is once we have the code, is actually send the code via the upload button. So let's go ahead and do that and see what that looks like. I'm going to go ahead and close the serial monitor. We're going to go back to output. See what happens.
Oh, interesting. Okay.
All right. So as we were messing around with the window, it uploaded or downloaded the code to the built-in memory on this chip.
Okay.
It says that this one uses 51,984 bytes, 19%, and the maximum you have is 262,144 bytes.
Oh, really?
Yeah, how about that?
Okay.
So we used as much as we used, and it's done. It wanted to give itself a pat on the back and told us how quickly it did it. Fine. But now that that's there, what we need to do is open the serial monitor.
Okay.
So part of the IDE up here is the serial monitor, and then we'll also look at the serial plotter in a minute. It's kind of cool. But the serial monitor is going to basically open up a phone call to the board and say, tell me numbers. So let's go ahead and do that.
Okay.
And there it is. It's telling us numbers.
So that's where it was set before. So if I take this, right?
Yep.
And I just turn it in any direction. Oh.
Yep.
0.
Yeah.
And I'm turning it very slowly. It seems really sensitive. What does it cap
It
at?
is.
Oh, it actually goes
0
1023.
to 1023, aka 1 to 1024.
Right. Okay, I see.
So I don't know if it did it here. No, it's just doing 1 to 1. In some instances, you'll want to map 0 to 123 to, let's say, 1 to 10, so that you only have 10 stops, so to speak.
Right.
But this is wide open. This is 0 to 1023.
It's the full width of
Yep.
every potential area of the potentiometer to hit.
Right. I mean, and that's, for the sake of that little potentiometer, that's very resolute. That's very fine resolution.
I see what you mean about noise, because it is jumping around a little bit, even though it's static right now, because it,
Right.
yeah.
There's just noise in the system. And there, I believe there's ways to get rid of that, but typically what you do is you say, okay, if it goes above 64, turn on a light. So as long as your noise doesn't push it above that, normally you're fine.
Okay.
So that's the serial monitor, and yeah, as you turn it, you are getting different values. This part's kind of cool. Numbers are fun. Graphical things are fun as well. So now we have a graph.
Whoa, okay.
So now try to move it a little bit. And you can see that the scale's changing frequently. You can make like a roller coaster. Going down. 0.
Invest in Bitcoin. Goes up, goes up. Oh, no.
It's like that. Oh,
Invest. No. Right. Line must go up. Look at that, and then it peaks. So
and it stops.
So it looks like it's pretty static at the max. So
Yeah, depending on how far you go in.
So if I pick a value here, so you can see that noise range.
The variance.
951, 0 to 95, almost 2, 3, sometimes 7. Interesting.
Yeah. So that is the serial plotter and the serial monitor. That's the very first basic sketch in the basics. And what we've done is we've used a potentiometer to hook into A0 analog pin and send values to a computer. Now, the cool thing is you could take this further on the computer side And you could have a program, like a Python program running in the background on the computer that's listening to the serial input. And basically, your Arduino can trigger some event on a computer.
Right, because it's just monitoring that signal.
Yep.
And it doesn't really affect the code here because this is just doing its own thing. It's on that end where it's receiving that signal.
Yep.
And this is just right out of the box when you get one of these. Like, this is just the first thing that you can do. 3 wires, a potentiometer, little breadboard.
Yep.
And you just drag and drop the code. And that's just a starter sort of sketch.
Yeah.
Where do we go from here?
Well, let's look. Back to the basics. This is called bare minimum. And I think what this is just, this is the very outline sketch, or the very minimum pieces you need for a sketch.
Right, bare minimum. That's what they called me in high school.
Oh, no. That doesn't even make sense.
I know.
There's,
I did the bare minimum, that's why.
oh, I get it. I get it. I get it now.
All B's. Anyway.
So this is the bare minimum sketch. And again, we already saw this with the last one. This is your setup section. Put your setup code here to run once, and then your loop, put your main code there to run repeatedly. So it's just kind of telling us there's nothing to do here. I mean, you could send it and nothing would happen.
There's nothing there. This is just what it would look like if you're starting.
Yeah.
There's your setup area, and then there's your loop area.
Yeah, you need to have this for it to work.
Interesting. Now, the 2 slashes just means that
yeah.
It's just a comment. It ignores that,
Yep.
right?
Yeah, so 2 slashes, if we were to put them here, this is just a comment, and you'll see it grayed out. Now, if you wanted to if you wanted to do multiple lines of comments for some reason, like write a paragraph, because the text would just go off the screen, what you can do is 1 slash, 1 asterisk. You see how it kind of already added the end?
Autocomplete.
Yep.
Yeah.
So, hello, this is Andy.
And it'll ignore everything between
Yep.
that section.
Yeah.
Very cool.
Yep.
So yeah, bare minimum really is the bare minimum. I mean, that's just your intro sort of code. It's kind of like just grabbing your pen and paper.
Yeah.
Right? Like, there's nothing there. You have to do the work to sort of add on to that.
Yep.
Where do we go from there?
All right, now let's look at the blink exercise, which a lot of people will say is the real hello world of Arduino.
Right.
And what we're going to do is
We're going to say hello world.
via...
Hello Dolly. No. Via an LED light. We're going to make it
There
blink.
you go. You got it. World's best cup of coffee.
I have to give you some banter every now and then.
Banter.
This is fun.
So this one, again, pretty straightforward, but this is kind of exciting because now we're experiencing an output from the board. This was an input. We changed the variables. This is an output. We changed the I don't know what we change. The voltage?
Yeah, it's just the voltage going through, right?
All right.
This is like a resistor, isn't it? Isn't that
Variable resistor. That's where I was going for.
That's what it is.
So a potentiometer is a variable resistor, and what we saw was us changing the resistance.
Right. Okay.
Right? Via a change in voltage? I don't know.
That sounds right.
Electronics.
Because if the 5...
We did like...
And stay tuned for more expert content.
It's over my head.
All right. You said, yeah, because it's the 5 volts coming out, right? And this is just changing the resistance.
It's changing the resistance, and we're seeing it through a drop and uptick of voltage.
Right.
And that's a fact. So now we're going to switch over to an output. Like we said, we're going to use an LED. If we look at the code over right here on the screen, we're going to hook into digital pin 13. So when we hook into digital pin 13, there's 2 things we need to know. And then there's also kind of a Easter egg too that we'll talk about. Not really that hidden, but we'll talk about it. So on an LED, when you have 2 legs like this, one is longer and one is shorter.
Right.
The longer one is going to be your positive lead, and the shorter one is going to be your negative.
Right.
When we hook it into pin 13, which is right here, we're going to put the longer in 13, and there just happens to be a ground pin right next to 13. So the shorter goes to ground. So in a circuit, I'm trying to remember if this is something I learned. We'll want to probably double check this because it'd be embarrassing if they were like, no, this isn't actually how it works. But in a circuit, when you hook a battery up to, like, let's say straight to an LED, one would think that the electrons all travel from positive to negative, but I believe it's the other way around.
Negative to positive.
Correct.
I've heard that before. I read that once about electricity travel.
Yeah. So we'll want to double check that. Don't ask AI.
Aren't electrons negatively charged, so they would be attracted to the positive lead? Isn't that how it works? So it
Probably.
comes from the negative.
Science.
Yeah, I vaguely remember that. That sounds familiar. If you're if you're a real electrician or physicist, please correct us in the comments below.
We apologize for our ignorance.
But we did plug this LED in pretty accurately, right?
Correct.
We got that right.
So the Easter egg is that there's already an LED on the board that is plugged into these two pins as well.
That's that guy right there.
Not the one that's... I think it's this one right here.
Right up there.
The L.
L for light. Right.
Sure, LED. Do you know what LED stands for?
Light emitting diode.
Very good.
Nice. I get cookies for every question I get right at the end of this.
Yeah. Cookies.
But I also get beatings for every question I get wrong.
No. So yeah, there's a built-in LED on the board. LED stands for light emitting diode, just like you said. You get cookies now. What we're going to do is we're going to just basically send this program that's already there, but let's look at it first. Again, super simple. There's your void setup. We're going to set something up. We'll tell you what we set up. Then void loop. We're going to do something over and over and over and over and over and over and over again. What we set up is the pin mode. We want to say that the pin mode is going to act as an output. And it's going to utilize the LED built in. So you might ask, well, what is that? Where did it get that? That's LED built-in call is built into the software, into the IDE, into the firmware of the device. What we're going to do down here now is digital write that built-in pin to high, meaning turn it on, wait a second, and then take it, turn it low, wait a second, take it, turn it on, and so on and so forth. So if we go ahead and send this, let's see what happens.
And while this compiles, be sure to shop at your local microcenter, where you can get electronic components like this.
Yeah.
We also have electrobits. We need a little commercial for electrobits.
Electrobits. Are you finding that your bits aren't electrified? Get electrobits. They brought out the Butterbot though.
Oh, didn't they make that into a robot or something?
Yeah, but who did it? It's like a kit. We carry them.
We carry the
Circuit
Butterbot.
Circuit Mess. Circuit Mess did it. I don't know if we have it. Hey, look what happened once we uploaded the code.
There we go.
The light, the one we plugged in, and the one on the board is blinking on and off every other second.
Look at that.
Yeah. If that doesn't make you feel good the first time you do it, you probably find a new hobby. But to me, that was like one of the most powerful things, is that I could send a message or a code from my computer to a device. And now if I want, honestly, I think I can take it out. I don't know if this will work or not.
Are you going to plug it into your phone?
Yeah, I probably should just done a 9-volt battery thing.
Oh, there you go. Power's up.
Yeah, USB-C power.
Look at that. So you can use any power source. That code is already on the chip,
Yes.
right? It's in the memory. It's not going anywhere until we erase it or overwrite it, basically.
Correct.
And you can have this on a power brick mounted on the wall and just have a flashing little light.
Yes.
But
Yep.
scale it up too, right?
You've done it.
You can wire up other things.
That's true.
So it's in sync with the little light on the board, right? So that
Yep.
little light runs to the same pin. Got it.
So obviously the thing we would want to do next is some tests. Like, what can we modify in this code to do something different?
Right.
So the first thing we can do is try to modify speed by editing the delay. So if we wanted it to be faster than a second, we could reduce that, let's say to
100 milliseconds? Or is
100. Let's see what
that
happens.
too fast?
I don't know. I can guess that it'll go up.
Yeah, because we have the other delay for the same,
Yeah, so it'll stay off, and then it'll come up.
and it'll go pop up.
Yep. So it is compiling the sketch right now, and once it's done, it will send the sketch out.
And you'll see over here, they have those two little LEDs.
Yes. So those are your serial LEDs. They show both transmit and receive. So they'll do a handshake with the computer and go back and forth, blinking on and off as they send the data to the microcontroller. Here they go.
So loading up.
Should be mostly receive.
Receiving, and, oh, you're right. Butt up. It reminds me of the lights they put on skyscrapers and airplanes that you see at night.
Yeah.
Like they kind of do that quick flash
Yes.
with a long gap in between.
Yep. Or you could also do it in such a way that it produces Morse code.
Oh, yeah.
So if we were to copy this code a whole bunch of times and do like SOS's,
So you could write LED built-in high, delay, low, delay, off, delay, and then copy paste that code over and over. But basically you just time out the delays to be the, what is it, dashes and
dots.
dots for
Yeah.
Morse code.
So right here would be
SOS is what, 3 long, 3 short, 3 long? Or is it 3 short?
3 short, 3 long, 3 short.
3 short, 3 long, 3 short.
So let's call it 500 for short. But what I'm going to do is I am going to leave a little bit of space after the first S. What did that do? 500. I'm going to leave it at 1,000, saying that the long blip is 1 second. So
Right.
this whole section right here is one letter S.
Right.
So if we wanted to, what we could do is just go grab this again. Copy, that's one letter. I'm going to just give myself some space so I know where I'm at.
Do you need that void loop written again, or you can just have it? I think you copied it twice, right?
Oh yeah, copied a lot of times. Yeah, you're right. So let's get rid of the void loop. Good catch, Jordan.
That's what I'm here for.
But what I'm going to do is leave a comment, letter S in Morse Code.
And that's the same as the first one we did, so now we just modify the middle.
Yep. Letter O in Morse code. It's always good to leave yourself notes. Or other people too.
Especially if you share your sketches.
Letter S in Morse code. All right, so what do we need to do to the O to make it work?
All right, so there's a 1 second pause in between. The O, they're dashes, so they're longer, so then they should be up for maybe a second each.
I think I messed something up. Okay, so the long ones, they're going to be off for the same amount of time, but they're going to be on for a whole
Longer.
second.
A whole second.
And then we're back to that.
Off for 1 second, and then the quicker flashes.
Yep, I think that's it.
Let's try it.
Riveting stuff. So again, it's going to compile the sketch. Compiles, like, it takes all the code and puts it down into a little package that it can send over to the chip on here, where it will run indefinitely as long as it has power.
And we didn't add anything. We just copied the same code that was already there.
Yep.
Just added it multiple times.
Copied it, modified it slightly. And now we have an SOS beacon as soon as it loads, which I believe I'm going to see the RX and TX light up in 3, 2, 1, go. Now. Hurry. Nope.
You're still loading. Oh, wait. Try it now.
3, 2, 1. Perfect timing.
Look at that.
First try.
Long. 1, 2, 3.
Yep. 1, 2, 3.
That's
S.
S. 1, 2, 3. That's your O.
Can you put like some suspenseful music behind this section?
Dun, 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 dun.
We did it.
But we made an SOS beacon. So
That's
now
cool.
we could just put this on a power source, make it waterproof, go chuck it in the ocean, and it's like an SOS like floating buoy or something, or
Yeah.
in case of emergency, power this on, and then you can have a light.
Yeah. I don't know if anybody's going to see that anywhere, but
Yeah, I mean, obviously you need a much bigger light, but that is an SOS beacon. That's actually kind of neat.
Yep.
And it was just easy. Like we literally just copy pasted what was already in the IDE.
right. So now we're on to digital read serial. Let's click on that and see what we're going to do.
Well, you can form the window.
Read the digital input on pin 2, prints the result to the serial monitor. This example code is in the public domain.
Oh, that's good.
So we are going to do a push button.
Okay. Do we need to find a push button?
We do. We need to find a button that's pushable.
I've got so many buttons. Is this a pushing button?
So many buttons.
Too many buttons. All right.
Too many buttons.
That one looks like it has 4 pins. I
Yep.
see one
That's fine.
that's smaller. This also has 4 pins. Okay, I guess that's the right amount of pins.
That's fine.
I'll
Get
just-
the other one out.
A little baby one.
Sure.
Get our
That's probably a 5 millimeter, and that's a 10 millimeter, and there's a 12 millimeter, and a 40 millimeter, and 1 millimeter.
buttons of all shapes and sizes.
Yep, this is probably one of your most common tack switches you'll find. Tack meaning tactile, meaning when you hit it, you're going to kind of feel a... So we got 2 buttons on here now. Do you have a little cap for this button? Like a little yellow or blue or green or red or... No caps? That's okay.
I've got like a little, I think this fits in there, no?
No, that's for that other potentiometer thing we did.
Let me see. It might be in the bigger box.
That's okay. We don't need it.
It's not electronics unless you're digging around in a box full of parts.
That's right. So we want to hook the button up to pin 2. But it doesn't say what else do you want to hook it up to, whether we want to hook it up to 5 volts or ground. I am going to make an assumption that we're going to hook it up to ground on the other side. So go ahead and plug in a lead to 2.
I'm going to clean up our
Yeah, let's get rid of that guy.
potentiometer really quick. And while I'm doing that, tell us about the breadboard here a little bit.
So the breadboard's cool.
You got little rows, columns.
Oh, you want more than... Okay.
Riveting!
The breadboard. The breadboard's cool. What that does is it helps you create circuits that are temporary quickly so that you're not having to solder. But the way it works is that there are 3 different parts, 4 if you want to get fancy, but there's 2 external rails, and what those are good for is plugging in your positive and your negative, or your positive and your ground, to have those available at any point on the board. And then this middle section, which is actually broken down into 2, has these shared columns or rows, depending on which way you're looking at it, of pins. So for instance, the way that this switch is laid out, in order to make a connection or to activate it or turn it on, you need to press it. Amazing. But what that does is it actually connects, let me see if I get this little lead here with the lead on this side. So what we're going to do is we're going to take number 2 to, I think it's in 25 on here.
So number 2, that's going to be our data. Right?
Yep.
So I'll make data.
Or positive voltage.
All right, I'll see 25. That looks like it. So I'll just plug that in. I'm just using really long cables.
That's okay. And then we're going to take this other side on 25. This is broken right here, this line. They do not share the whole way across. They only share on their side of the river.
And this is bridging that gap.
Yep.
I'll plug this into a ground here.
Plug it into a ground. And now we need to run the code. So.
Should I take this LED out?
Sure.
Or can we use the LED?
We could.
I'll leave it there for now. We'll see what happens, I guess.
So let's go ahead and send this. We're going to use our serial monitor again. We've already done the read analog serial. Now we're doing read digital serial. And in fact, if we look at the code, let's see what it's doing. We're setting up the serial again, and we're setting up the pin mode like we did in the past couple of examples. And now we're going to read the state of the button, and then print the button state, and then wait a second. So I'm guessing what it's going to do is like off, 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 and then on if you press it. Or maybe it's a 0 and then a 1 if you press it.
Right.
So let's see what happens. We're going to need to open our serial monitor.
I'll get my pressing finger ready.
Done uploading. Ah, just as we suspected, a whole bunch of zeros. Nothing.
Is it the ground or is it the 5 volt?
Do the 5 volt. Let's see what
I
happens
think it was
then.
the 5 volt. Ah. Now we're getting all ones.
Well, so the next thing to troubleshoot is, did I lie to you about the button? So,
Do we have it oriented correctly?
was that 27?
Looks like it.
There it is. So I lied, and the button's actually connected by the 2 things on this side.
Is it? It's not changing.
It did just a second ago.
Because it was unplugged. Watch. So when I unplug it, what if it's this?
Riveting.
What if I try a different button?
So what we should have done, what we're going to do now, is we're going to go ahead and click on this link. And we're going to go over to our favorite handy dandy browser. Digital serial read. If something's not working, always check out the docs. I'm guessing what it's going to tell us is that we didn't hook it up nearly correctly.
Nope, we're nowhere right.
Yep, nowhere close to right. So let's go ahead and hook it up as it shows here. It's asking us to use 10,000 ohm resistor. I'm going to go ahead and say that whatever resistor you find is probably going to be all right. But if you want to be specific, color code for 10K ohm resistor. We need to find a brown, black, orange, gold.
Brown, black, orange, gold.
And we will also need...
Brown, black, orange, gold. Found
Nice.
it. Okay, so we're going to redo the wiring. We jumped the gun on this one.
We did. And I'll explain what I think is going on here. Just like we had in the previous circuit, we had some noise with the potentiometer. There's also noise in the circuit, even on the digital lines. So what they're going to use the resistor to do is either be a pull up or pull down. And what that does is it basically makes it sure it's off all the time or on all the time, depending on which way you set it. So here we're going to use a as a pull-down resistor to the ground. So we want to make that resistor go to the ground.
Here, pull up the little diagram for you. Make it nice and big on the screen. Yeah, there we go. All right, so let me start with, I have my data. So it looks like 2.
Data is up on one of the top legs.
Okay.
And then on the bottom leg, we can skip the rail if you want. We can put the red right into what's not data on the other side. If that makes sense. So put the voltage into 25.
I want to follow their color schematics. Hold on.
Okay.
So you want to make white their blue.
Yep.
So I'll make that data. So I'm plugging this into pin number 2.
Mm-hmm.
I'm going to plug this into row 25 here where the button is.
Yep.
The red I'm going to put on 25 over there. And this is going to go to our 5 volt.
Yep. But actually, their data is on the pin opposite of the voltage. So you'll want to switch 25 to 27 with the data. I guess probably the right thing to do, folks at home, is actually put your components on the board where they are. But I think we got it.
So I've got our resistor. Just put it on like.
Yep, on D. And then to ground. So right now you're hooking up this side, and you're going to skip the rail and go straight to ground. Okay. Allow us to go back and see now what happens.
So it's the same code loaded up.
Yep.
And then, aha. I'm holding it. It's 1. I'm letting go.
Mm-hmm.
It's 0.
Yep. Ta-da.
Now, how do we add to that to make the light turn on? Yeah, that goes so fast.
Yeah.
Oh, wait, but hold on. If you bring that up,
Yep.
I can do my SOS.
Oh, yeah.
1, 2, 3. 1, 2, 3. 1, 2, 3. It's just going by so fast.
Nailed it. First try.
Look at that. I could save the Titanic. All right, so.
You want to add this so that when you click the button, the LED comes on.
Can we just copy the code from the previous sketch and add it to that? Or would that?
Let's go look. Let's go look at that LED code and see what we can do. Blink. All right, so in the setup, we're going to find that we need to initiate a pin for the LED. Mm-hmm. And we'll go ahead and keep that. So we'll go ahead and copy this part into digital read serial into its setup. Let me minimize this a little bit. So now we've got 2 things in the setup. We're setting up, well, actually 3. We're setting up serial. Mm-hmm. We're setting up the push button as an input type, and we're setting up the built-in LED as an output. Mm-hmm. Here's where it gets fun, and I might need some help. So, basically what we're going to do is have it digital write to that. Digital write LED built-in high. And I don't even think we're going to need delay. Let's try this. Go over here. Okay. So void loop, initialize that, print button, state. So that's just always doing it. Mm-hmm. We need like an if statement. If the state is 1, then turn the light on.
Right.
And if not, turn it off. So I don't know. Let's go check quick. There might be an example of this. Digital button. We might be skipping ahead. But let's see. Turns off a light emitting diode connected to pin 13 when pressing a push button attached to pin 2.
Oh.
This is it.
We are jumping ahead. Well, before we jump ahead then, how do we round out the basics? What's left on the basics front? Because it seems like we're ready to like start leaping forward, as I'm sure you are too.
So we've got two more things. We've got fade, which is basically just making the LED fade up and down. Now, in order to fade, you'll see that we need to hook it up to a specific pin or a specific type of pin. Not all pins can make the LED fade. We're going to do LED on pin 9 because pin 9, like a few of these others, have what's called pulse width modulation.
Okay.
And to make something fade up and down, it's going to use kind of a trick against your eyes. It's going to blink at certain rates, and the faster it blinks, the brighter it will seem.
Right.
Right? We'll see. So we need to go LED from ground to pin 9.
These buttons in there, good.
Oh yeah,
There we go.
good buttons.
That's a strong button. There we go. That's a nice piece of tape holding that in place. So I'm going to put the LED here,
Yep.
right? I'm going to put one in one in the other.
Yep. Remember which one's positive?
Number 15.
Cool. So 15 goes to 9.
Then 14.
14 goes to ground. And I'm going to go ahead and start compiling it. There's some other things happening in here now outside of the setup, I think for the first time. And what this is doing is it is some of those naming things or some of those values of things that are already built into the firmware. So we're calling an LED, it equals pin 9. We're going to set the brightness to 0. That's how bright the LED is. And then the fade amount, how many points it fades by. So this one might be a little bit jumpy. It might go dut, 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 dut. So we'll see that here in a second.
And then for the setup, it just says pin mode LED output. Okay.
So we've already told it. You could theoretically, you could just put 9 here, and it will know pin 9. But since we've called pin 9 LED up here, gave it a name.
It's just calling to what's established at the beginning. Very cool.
Yep.
So that way, if you ever want to change anything, you just change it at the beginning, and it'll apply it to the whole code that's referencing
Right.
that LED versus
Right.
having to go through and
9999999. Yeah, exactly.
Smart. I'm not even a coder, but that's
Computers.
yeah, computers. It's
Well,
all about
there it goes.
efficiencies, right? Oh, I see it.
Yeah.
Oh, so it's smoother. But
Yep.
I see what you're meaning because there is kind of like a little flicker. I wonder if it shows like that on the camera at all. But there's a little flicker to it, but it's just going.
Yep.
Wah. And I know before we were trying to jump ahead to get the button with the LED, but it seems like some of this might tie into that connection. So maybe it's good we didn't jump ahead too much.
Yeah, there's other things that we're going to need to know, but this one to me, now I want to say, okay, what else did we learn about earlier? The potentiometer. How could you have the potentiometer interact with the pulsing of the LED?
Right.
Either by brightness or by speed, depending on how high the potentiometer is. So that gets us to our last sketch for this, and we're going to go to read analog voltage.
Your laptop's gonna die.
I know.
Do you want to
It's
charge it?
at 19%. We got this.
Push it to the limit. Limit.
So this one, read analog voltage, we're going to read an analog input on pin 0. It's going to convert it to voltage and print the results to the serial monitor. Graphical representation is available using the serial plotter. We've used that before. Attach the center pin of a potentiometer to pin A0, the outside pins to 5 and ground.
Interesting.
Yep.
So let me stretch some of these out.
So we actually have to redo what we undid.
That's fine.
Undid what we redid. Do. Redo.
So 15, 16, 17.
Yep.
I'm going to use that on the breadboard going across. So the center pin of the potentiometer.
I'll tell you what. I bet if we follow this link,
Let's bring up that doc because those pictures help.
we'll get a pretty picture.
I'm a visual learner. Ayo.
Really? Wait a second.
What?
Something doesn't seem right. Read analog voltage. Oh, okay. I see. Okay. Pretty straightforward.
So the digital stuff is on this side, analog's on this side,
Yep.
right? So that's what we're focusing on.
Yep.
So I have the middle pin,
Mm-hmm.
and I'm going to run the middle pin to
A0.
A0 on the analog side.
Correct.
Over here. And then our ground.
To one side and 5 volts to the other. It doesn't really matter which side, as long as it's one of the outside pins.
Got it. Okay.
There's so many ideas.
I know, right? It's hard to contain them all. My wiring's a little in the way, but you get the idea. There she is.
Yep. Okay, let's go ahead and send the code and see what happens. While we're sending the code, let's talk about it. So again, we've seen this before. Void set up serial. That's going to let us talk back and forth the computer. And then the loop, we are going to initialize sensor value to analog read on A0. I believe this function's already built in, or it's a variable here. Actually, it's saying. And then float is going to float the voltage equals sensor value times 0.5 to 1023. This is what we were talking about earlier when you want to map an input to a different input.
Right.
So this is saying that we normally see 0 to 1023, but all we want to see here is 0 to 5.
Right.
So it's not that there's less of the potentiometer you're using, it's more that it's changing the scale of the numbers you see on the potentiometer.
So that's one side of the equation is 5 volts. So depending on, 5 being the max, 1023 being the max, and then as that 5 volts lowers, that ratio will
Correct.
reflect on the 1023 side.
This line of commenting probably describes it better than
Probably, yeah.
what I just said. So
Me too.
Print
Convert
out
the
the
analog
value
reading, which goes from 0 to 123 to a voltage 0 to 5. Yeah, see? That's more concise.
right? So serial plotter. Let's go to the monitor first. So we're at 1.9 volts. 3.2 can turn all the way up to 5. You do get.
5 volts.
All right, let's see our serial plotter. I think this is what it was trying to show us earlier. Yeah. Okay. That's it. However, let me try one thing since we have this set up. That's great that we can see it visually that way, but I'm almost curious if there's a way to see it by hooking an LED up.
You
I
have to
figure
the
out.
LED into the...
Yeah, I have to think about this for a second.
So
So the output of the, okay.
the output's going to have to go somewhere through the LED.
Yep.
Is that what it is?
Yep. Let me try something.
Well, no, I think you pull it out of the board, route it into something.
So that was the ground I just took a hit of.
No, that's the 5 volt.
Oh, on that side?
Yeah. Ground is the black.
Although you might be right, actually. So if it travels from there, hold on. Ground. 5 volt.
It has to interrupt one of the signals now.
I bet we're going to discover that in a future lesson.
Yeah, you're cranked 5 volts.
I think that's it, though. If this doesn't work, we will do an outro. Oh, yeah, you're right. There's more to it.
it gets complex. So that covers the first intro chapter.
The basics, 0, 1, the basics.
Back to basics, just for Arduinos. So if you're starting with an Arduino, that is just the first couple of lessons, but we're going to dive into the following lessons. How many more are there? Because there's a lot of sketches.
There are a lot. So we did 0, 1 up to 11, if we get that far.
Cool.
And this one actually uses a specific kit, which we do sell. And there's a lot of like fun project type things. So it'll be cool when we get to that. But there's going to be a lot of other good basic things. And the idea is that with these building blocks, you start to say, oh, I have this tool. I can do this now. I have this tool in my tool belt. I can do this now.
Right.
And every time we go through a section, you're going to gain more tools.
Right.
Or better understanding of tools and how they work together.
Cool. Follow along in real time. If you get yourself an Arduino, get yourself these components. We're just going to do this long. Just follow along with us in real time as we go through. And stay tuned. We'll catch you in the next one.